The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
When Newark sent me this portable power supply, I had an idea for a skit where I tried to pack my large bench supply into a suitcase. And then this happened. I can't even lift that supply off my bench right now. So it's kind of funny how things work out. Hi, I'm James and welcome back to Workbench Wednesdays. In this video, I review the Tenma portable power supply. First up, let's take a look at the specs for this supply. It operates on an AC input voltage from 90 to 265 volts, which means it should work pretty much anywhere in the world. It can output up to 30 volts and up to 4 amps of current. However, it is only a 50-watt supply, so it can't do both. Above 12 volts, it can only output 1.6 amps. Its noise is specified from 20 Hz to 20 MHz as less than 10 millivolts RMS or 100 millivolts peak to peak. If you read the datasheet carefully, you might notice that the minimum output voltage is 300 millivolts and not 0 volts. At the time of making this video, the supply is normally sold for $140 US. As you can see here, the price is currently less than $100. So I'm thinking if this supply can really support 50 watts at that price, it's going to be a great value. Now, I am going to get to some performance measurements, but first I want to talk about its form factor. Shown here, you can see that the power supply is roughly the same size as a handheld multimeter. On the input, there is a standard IEC 320 C7 non-polarized connector, which means you should be able to find a cord that matches the plugs in your country. The screen is bright and easy to read. The big buttons make it obvious where to press. However, these are kind of squishy. Now, I'm not really complaining about them, but they don't really make me all that excited either. In terms of voltage output, there are 2 banana plugs as well as 2 USB power-only ports. Using the buttons is straightforward. When in display mode, up and down control the backlight, while left and right change the contrast. Let me just pause for a moment and say, on camera, the screen isn't coming out as well as I can see it in person. It's actually very sharp and easy to read in person. So I'm doing my best to capture it on camera. I'm going to use a little bit of post-processing so that you see what I see, or at least something that's really close to it. Holding down set goes into settings mode where we can set the output voltage or the maximum current. There is a memory function that can store like 4 presets. However, I didn't really use that. The output itself can be turned on and off, but there is no power switch for the actual AC coming in. One more thing before we get to testing, I'm not happy with the included leads. They're probably better than nothing, but that's not saying much. So in this video, I'm using some leads that I got from Newark, which are also from Tenma. Opening up the supply shows there are 2 boards, a digital board to control the front panel, and an analog board for all of the power supply business. It's amazing to me how much stuff is packed into this case. Overall, the design is clean and relatively easy to follow. I did think it's kind of funny that there is a silk screen spot for a fan, even though the box clearly says no fan. It just made me wonder, at some point was there going to be one? I haven't studied the analog board in detail, but it looks like it converts the incoming AC into 38 volts DC. A buck converter drops the voltage down from there. On the digital board, there is an STM32 microcontroller. On its PCB, there is an ARM programming port and signals that look like a UART or serial port. Looking around, I'm left wondering a couple of things. Number 1, why isn't there an AC power switch? There's plenty of space for one. Number 2 is it possible to run this supply from a DC source like a battery pack? And third, what kind of stuff can be done with those 2 exposed digital interfaces? Now, before we get carried away with future hacks, let's go to the bench and make some basic measurements to see how it performs. For the first test, I have a Raspberry Pi connected to the USB ports. When the USB port is enabled, the output voltage is automatically set to 5.1 volts, which you can't change, and the current limit is set to 2.5 amps, which you can change. As the Pi boots, we can use the built-in current meter to see how much current it is drawing. Now, I do want to point out that when the USB ports are active, so are the banana jacks. So that means you get 5.1 volts out there as well. However, when the USB port is disabled, the voltage from the banana jacks does not make its way back to the USB port. Now that my Pi is booted, we can see that it's drawing between 400 and 500 milliamps. In my lab, I have 100 volts AC. For parts of the world with 220 volts, let's use a step-up transformer to make sure that this supply will work for you. I am using an EU-style IEC cord. I just plug it in, turn on the transformer, and the power supply boots. I'll turn on the Pi just to show that it's also working. No shocks there. Get it? Shocks. Okay, moving on. A reason to use a bench power supply is to get both voltage and current limiting. For example, when you turn on a circuit board for the first time, you can set your voltage to 5 volts and a maximum current of 100 milliamps. That way, if there's a short in the circuit, the board can be protected. To test that feature of this supply, let's use this reel of RGB LEDs. Right now, I have an Arduino controlling each color through a transistor. Using the built-in current meter, you can see that each color draws around 300 milliamps. When I turn on all 3 colors, the strand draws about 1 amp of current. Here's how current limiting works on a supply like this one. As I turn down the maximum current, you'll notice the LEDs are getting dimmer. Switching the supply's meter over to voltage shows that the output voltage is dropping. Even though I set the voltage to 12 volts, the current limit means that the output voltage must drop as well. It also means that this feature is working the same as it would on a bench supply. Now let's test the limits using my scope and electronic load. First, at 12 volts, the maximum current the supply lets me set is 3.75 amps, which is only 45 watts. On the scope, the peak-to-peak noise seems high. The 250 millivolts peak-to-peak and 14 millivolts RMS is larger than the specified ripple. For comparison, let's look at the same conditions with a regular bench supply. This Tenma 722690 is rated for 80 watts, and its ripple is less than 15 millivolts peak-to-peak with only 2 millivolts of RMS. Watch what happens when I turn off both the load and supply. The measurement on the scope doesn't change very much. So the bench supply is quieter than the measurement floor of my setup. Okay, going back to the portable supply, let's test its maximum of 30 volts. In this case, I can only set the supply to 1.6 amps. And when I turn my load, it starts pushing 45 watts, which gives us quite a bit of noise. However, it is a little bit less while we're using this lower current. For the last noise test, I set the supply to 12 volts and 1 amp like we used with the LEDs. And here I'm getting values well within the specified limits of the datasheet. So what do all of these measurements mean? Well, first, recognize that the noise floor of my measurement setup affects the results. So based on these numbers, I've come up with 2 conclusions. First, the datasheet is slightly optimistic. The supply self-limits itself to 45 watts. And second, the ripple noise is significantly higher than a traditional bench supply. But for a variable switch mode design in a small compact case, I pretty much expected that. Now, I do need to talk about a problem that I encountered. For all of these measurements, I had the scope set to AC coupling with a 20 MHz hardware low-pass filter and a 20 Hz software high-pass filter. This bandpass is the normal range to measure ripple noise. When I turned off everything, I noticed something odd. Here, the load and supply are off. Looking at the scope, this line on the screen is 0 volts. Do you notice anything odd? Even though the supply is off, it is outputting negative 450 millivolts. So for the next measurement, I decided to do something you should never do, which is connect the supply directly to a current meter. When the supply is supposed to be off, there's about 360 microamps flowing. For most situations, this won't be a problem, but it does bother me that when the supply is supposed to be off, it's not sitting at 0 volts. Okay, I'm going to cut in here real quick. I'm already done editing the video, but since I finished, two things have happened. First, my arm has gotten better, and second, I found a solution to the negative voltage problem when the output is turned off. So check this out. The fix involves removing a transistor and replacing two capacitors with resistors. The capacitors appear to be the same regardless of which version of the PCB you have. However, I did find that the transistor is different depending on the PCB version. So like on my supply, I have the fan silkscreen that I mentioned earlier. So what you want to remove is this transistor. If you don't have that fan silkscreen, it may be the transistor that's next to it. The easiest way to tell is to look for a trace that runs between the transistor and the pin header. That's the one you remove. As for the capacitors and resistors, you remove these two ceramic capacitors and replace it with a 50 ohm resistor. Now in my case, I had a 47 ohm and I only had an 805, while these parts appear to be a 1206. So the soldering looks a little bit funny because they didn't fit perfectly. In terms of making this fix, it's relatively simple if you're familiar with working with surface mount parts. If you have a hot air station, it's very quick. If you have to use a traditional soldering iron tip, then just make sure you have something that's really fine tip and take your time. One tip I'll give you is I removed this big capacitor when doing my work so that I had more room to work. If I didn't have the hot air station, I would have also taken the time to remove this pin header and then just put a new one in when I was done. Now that the mod is complete, let's take a look at my scope. The white trace is before the mod, the yellow trace is after. So if you look at the white trace, you can see that the power supply turned off slowly and then went down to about negative 0.6 volts. After the mod, the power supply turns off very quickly, but most importantly, it goes directly to 0 volts. So keep this mod in mind when I get to the conclusion because, past James didn't know about the fix. The thing I like most about this supply is its form factor. Most of the time, I don't need a precision voltage source. I just need something that's adjustable. And so while the Tenma portable supply's 50 watt output and analog performance isn't the same as a dedicated bench supply, it is above average and more than adequate for most situations. The user interface is relatively simple and the screen is easy to read, at least off camera. I really do like the USB ports and the fact that they can measure the current of a device that's plugged in. It would be nice if they worked independently from the adjustable output, but that's just a nitpick. In fact, most of my negative things to say are the nitpicks I already mentioned. The buttons don't feel all that great and there isn't an AC power switch. However, I'm dancing around the negative output voltage issue. While that off voltage may not be a problem when powering something like a strand of LEDs, I am a little bit concerned about other applications. Overall, would I buy one of these myself or recommend that you buy one? Well, the answer is yes. Even with that off issue, I think for about $100, this is a great supply to have on hand. I would not recommend it as your only bench supply, however. For the same price, this higher power and cleaner supply is a better choice for a first-time buy. And remember, if you do buy one of these portable supplies, I recommend getting some different leads to use with it. I'll include links in the show notes for the Tenma leads that I used in this video. For more information on these products, to ask some questions, or even suggest hacks for the Tenma supply, head over to element14.com/workbenchwednesdays. I'll include some links and additional information. It's really funny to me that I injured my shoulder right before this video. I have some other projects I need to work on, and so I will actually be using this supply until I can lift my heavier one off my bench. Speaking of which, it's time for me to get back to my electronics workbench.